So last time we stopped at the end of chapter 9, and we are going to start with chapter 10, which is basically dealing with the exceptions. And exceptions are an important part of the design of your application. So you would like to catch and deal with the exceptions in the proper manner, such that your application will run correctly and properly when you implement it. So if you look into the chapter contents in chapter 10, basically what we are going to focus on is, first of all, the purpose of exceptions. Why do we deal with exceptions in the first place? And then the exception messages, how they are generated, the stack, and then also the try-catch statement. In addition to that, the finally block. And we will have propagating the exceptions towards the main method, how we can generate exceptions and propagate them, and the exception class hierarchy. In this part we will deal with exceptions that are checked and unchecked. So most of these we are going to cover mostly today, and then we will see a couple of additional GUI components such as the tooltips and mnemonics, and also some split panes and additional couple of more GUI items, which might be again useful for your projects and in your designs. So the exception handling, if we consider an exception is an object that describes an erroneous state or a problematic situation or an unusual case where your application needs to perform differently. So if you have an unusual event that happened, you would like to react to that by performing some task, and that's what exception means. And you can throw exceptions by a program, so there might be a problem in the program and the exception may be thrown, or you can throw it by yourself within the program whenever you think there's a problem. So program either throws it, or you can explicitly throw the exception by yourself as well. This can be whenever there's an exception there. There are three types of things that you can do. One is to ignore the exception. The second one is to catch it where it actually happened, or the third one is to catch it somewhere else. So you have three different options. Normally, a program execution can be divided into two parts. One is the regular execution, and then the other one is the exceptional cases, in terms of whenever there's an exception, what's going to happen, how are you going to react to that. So there are two types of program pieces. One is regular, the other one is exceptional cases. And also error is considered to be somewhat similar to exceptions. However, it's different in the sense that in errors you can't do anything. You cannot basically catch it or try to fix it or things like those. You can't do it because, for example, let's say you open the file and reading from a file. What happens is that if the for some reason hard drive fails and you can no longer read from the file, then there is nothing you can do. There's nothing you can fix for that, and these cases are considered errors. However, exceptions are things that you can handle and things that you can try to at least try to solve it with a minimal impact as much as possible. So that's what exception is. So there are, Java provides predefined exception libraries. So there's an exception class that is part of the object. So basically the class hierarchy is that object. You have a throwable, and then you have the exceptions, and also you have the error class. So this is the hierarchy for the exceptions, and Java already provides a set of exceptions which are children of this exceptions class. So basically you can use those exceptions available to you in your implementation. As I said earlier, whenever there's an exception, either you will ignore it, meaning that you won't do anything to it, and then it will just propagate towards the main method, and then it will finally end your whole program, so you will ignore it. Or handle it where it occurs. So let's say your method have this exception, let's say divide by 0. Okay, this is an exception. If this is an exception that is happening in a method, you can handle this within this single method or wherever this was called before. So let's say this is a method name test, and then you are calling, let's say I have public void test, and then you have a certain implementation which causes this divide by zero exception. In this case, you can handle it within this method, or you can handle it wherever this was called. Let's say there's another method which calls test. So you can also handle it here, meaning that you may want to resolve the problem in the caller of the test method. So there are three choices for you to take care of the exception. If you would like to ignore it, that's also possible as an option. In which case, the whole application will terminate abnormally and give you the error message at the end saying that, hey, this blah, blah, blah happened due to this. So as I said earlier, exception handling is important in your designs as well. If you ignore the exception, the program will terminate abnormally and produce an appropriate message. So you will just finish the application without any results, and then you'll get a message what caused this and which line in your code this was actually happened. The message includes a call stack trace which gives you the line on which the exception occurred and shows the method that the call caused the exception. So for example, the call stack, what we mean by the call stack is that, what's a stack? So what's a stack? For example, stack of, let's say, plates. So you have a stack of plates that are sitting on one another. So basically, stack is something like this. So you have a stack of plates, for example. So whenever you put an additional plate, it goes on top of the others. And if you consider this structure, what kind of structure is this? Is it first in, first out? So this is not first in, first out. If you have a first in, first out, you could have something like this empty, and then you take it from the bottom. That is going to be a first in, first out. However, if you're popping from here and also pushing to the top of the stack, this is the stack mentality. So stack takes from the top and pushes to the top also. In this case, what you have is not first in, first out. What you have is last in, first out, which is also called LIFO. For first in, first out, what you call is FIFO. First in, first out. Last in, first out is the stack structure. So in call stack, what we mean by call stack is that, let's say you have a main method, and then that calls method A, and then that calls method B, and then that calls method C. So what happens is that in the call stack, you're going to basically have a stack of, like the plates, you will have a stack of method calls. So you will have the main at the bottom, which calls A, which calls B, and then which calls C. So it's going to basically pop up each method, and then until it reaches main method, it will print all those required messages to indicate the call stack, which methods actually was part of this this exception will be printed on the screen. So it will basically happen due to C, then after that comes B, and then after that comes A, and then finally you see it in the main. So you can see each line of the code where this actually happened in the exception. Okay. So if you see this 0.java example, let's open that up. So this is basically a simple application, public class 0, and then you have public static void main, and you have int numerator 10, int denominator 0, and then you have a system out print line numerator divided by denominator, and then there's another string at the end. So what's going to happen if I try to compile this? Compile this. Can I compile it? Is there any syntactic error here? No, there's no syntax error. However, what kind of error am I going to receive if I run this? Runtime error, because I'm trying to divide 10 by 0, which is going to cause a divide by 0 error, and an exception will be generated. So if you want to compile, it will perfectly compile as here. And then if you want to execute it, however, as you see, exception in thread main, so this is the first place that the exception actually is seen. And then where is it happening? Java.lang.arithmetic exception. So this is the type of the exception, and this is divide by 0 exception is shown there. And also it gives you where it happened. It happened 0.main, the method of the exception, and then the line 0.java on line 17. Okay, so that's basically the main exception. If you do not handle this exception, it's going to, it's going to just finish your application and you'll get this error. So this is called runtime exception. Runtime exceptions do not need to be checked, so you don't need to check for runtime exceptions. However, such as I/O exceptions, you have to check them. What do we mean by checking? I will explain it further on. Okay. Try-catch statement. Basically, you can catch exceptions by using a try-catch block. So if you have a line that is going to possibly throw an exception, you can put it in between try-catch statements to catch it before all the application finishes its execution. So you try to prevent an abnormal finish. Instead of that, you would like to perform a specific task to correct the exception problem. Each catch clause has an associated exception type and is called an exception handler. So let's say there could be more than one exception. One could be, for example, array index out of bounds exception, right? If you remember, we have seen that if you try to access an array element that doesn't exist, you'll get array index out of bounds exception. Or you can get, let's say, an arithmetic exception as this one. So you can have separate catch statements to catch these exceptions individually and perform specific things on those. So if an exception happens, processing continues at the first catch clause that matches the exception type. So what you do is that you will try to first catch it with the first catch. If you cannot catch it, you can continue with the next catch and so on. So the main block is composed of something like this. So let's say I'd like to do this same division. So I have a try block. Basically, you write whatever your code that could generate an exception in these parentheses in the try block. Then you have the catch, and you give the exception type. So as I said earlier, exception is going to be the parent of all exception classes. So you can catch any exception by the exception class. So you can catch it by this, and then you can have a certain thing that you would like to do when you catch the exception. Okay, so this is a catch block. However, let's say if I would like to have more than one exception and specific exceptions, I can say, hey, I'd like to say that catch, if I catch an exception that is type of, let's say, that's type of array index out of bounds exception. Exception E. Then I will perform this specific task. However, if this was not the exception, however, if the exception is catch, let's say, string, let's say, anything like arithmetic exception, let's say. If the exception is this type, it's not going to be caught by this catch. However, it will be caught by this catch. So you will perform whatever you are going to do in this case, okay? And you can have multiple catch statements, whichever fits perfectly with the exception you have, it's going to be executing that part only. Okay? So what happens if I have, let's say, a statement here, statement 1, statement 2, and then I have statement 3. And somehow, my statement 2 generates an arithmetic exception. So what's going to happen? So this generates an arithmetic exception. How is it going to execute from that point on? What do you think? Is it going to execute statement 3? It generated the exception, so it's not going to execute this statement at all. The statement will not be executed, and then it will not be caught by this catch. However, it will be caught by this catch, and whatever is done here is going to be performed. After this whole try catch block, it will continue execution from this point on. So it will start here, execute the statement 1. Statement 2 will be tried, and it will generate an exception. Then you won't execute statement 3 and jump into this catch, execute this part, and then continue from this point on. Okay, so execution continues. If you didn't have this try catch, what was going to happen? You will just exit at this statement 2, and the whole thing will be finished. The whole application will exit, right? Any question? So when an exception occurs, processing continues at the first catch clause that matches the exception type. So whichever matches first, it will continue from that point. However, after the catch, you will continue execution with the remaining lines of code in your application. So let's see this product codes.java.
Ya apayrı bir exception olsaydı, aritmetik değil mesela, ikisi de tutamadı, o zaman ne olacak?
In that case, you're not going, if the exception is none of these exceptions, if you have an exception that's not caught either one of these exceptions, it's going to behave like as if there was no try catch statements. Okay? It will be caught at the end by the main method, but main method does not know what to do with that error, so it will just exit the whole thing. So if you look into the product codes, you see that here, this is the main method, and there, string code. There's char zone, and these are all defined variables you have. And then the user enters an input using the scanner. So you read the code, scan next line, enter product code. So it's basically accepting while not code equals xxx. So the exit condition is xxx, right? So the user will, whenever you type xxx, it's going to quit because it says enter product code or xxx to quit. And if you look into the while loop, basically what it does is that you have the try. This is a reserved word for Java, so you cannot use it for anything else. That's why it's in blue, right? And then I have the try block. So you try to get the zone by checking the code char at 9. So you basically try to get the character at position 9. However, if you try to write a code that is less than 9, what's going to happen here? Let's say if I have a code that is typed as 3 characters, you will get an exception, a runtime exception basically. And if you look into here, catch string index out of bounds exception. So basically, this is catching that index out of bounds exception by using this. If there's an exception here, it's basically will be generated and will be caught here by saying, hey, improper code length. And then after that, it basically continues with the while loop again to ask for a new line here, as you see, enter product code or quit with xxx. So even if you have not succeeded with the first try, if you catch this improper code length, you're going to basically, after finishing this catch statement, you will continue with this line and then continue execution with the while loop again. Okay? So if I didn't have this try catch, what was going to happen? The whole application would have exited the running, so it's not going to continue to run. However, with the try catch, what you're ensuring is that you continue with the next iteration of the while loop. Obviously, you could have done this instead of with the try catch block. How could you do with the general programming concepts that you know so far? Nothing new, nothing that you don't know. So whatever you know so far, how can you prevent something like this happens, an error like this happens? So I would like to prevent that this doesn't give me an error. Fast? If else, yeah, exactly. So if you check the size of this code code size, right, the length of this code string, then you can also perform it. However, this try-catch statements provide you a nice, implementation, because you write everything here. The code is written here. You do not clutter it with if-else statements. And then if there are any problematic things that you want to catch, you catch them at the end as a whole. So it will catch either this line of code. Also, it will check another line of code that you may have. So in this case, let's say if you have another line, zone 2, right? Let's say I have another int zone 2 that's defined before, and I have, again, let's say I have code char at 10, code 1, code 2 char at 10. So this is basically going to generate an exception for both of these. This string index out of bounds exception. However, if you were to write both of these using if and else statements, you would have had a complex and complicated if else statements to get the char in these two positions, right? You need to check both code 1 in terms of the length of the string, and for code 2 as well. So try-catch blocks provide a nicer implementation, which you can also achieve, using throws statements, as I will show shortly. So going back to the original code here, and there's another catch statement here. What does it catch? Number format exception. What is this for? Why do I need this catch statement for? So basically, if you would like to parse the integer that is given as a code substring here, the substring that is generated, what happens if the entered values are not, numeric characters? So if you cannot get a numeric character from the user, if he or she enters alphabetic characters, for example, in that case, the parse int is not going to be able to convert it into an integer, right? The integer class. So in that case, you'll get a number format exception, which is going to be, printing this district is not numeric, and then it will type whatever is entered by the user. So both of these will prevent these two errors, and then, if you look into the while loop, it will go over again and again until you type XXX. So let's run this. So if you look into your enter product code, if I enter something that's short, such as 1, 2, 3, it gives me improper code length, and then it asks me again. So it doesn't exit the whole thing, so it continues to run, right? If I have something like, and then I have y, so that it's going to get the substring between what was the number 3 to 7. So it will try to get the substring 3 to 7, which will probably give a numeric error. So district is not numeric, so it prints the value afterwards. Okay? And you can just quit with XXX. Any question about this product codes? So basically, you can have additional catch statements. After this catch statement, you may have another catch which is proper for the code that you have written. However, you have to decide what kind of catch you would like to have in the code. It depends on the code you have here. Since you know that this could be possible that the string may not have a length of 9, you would like to have this. If you think that this could be generated, you would like to have this. So it's up to you to design those exceptions and exceptional cases. The finally clause, actually this is also a really useful thing. So after the try catch statements, so I have try and catch. Let me erase this second catch. What you do is you can add a finally clause. Basically, again you have some lines of code here. So what's going to happen is that it is going to try this statement. Let's say this generated the array index out of bounds exception. So let's say this is array index out of bounds exception. And in that case, what's going to happen, as I said earlier, it's not going to execute statement 3 and jump into the catch. It will catch this exception and execute the lines of code here. Then after that, it is going to continue with the finally. So what finally is used for is either you have an error, you will continue from here. Either you finish the try part successfully, you will continue from here. Okay? Even if you get an exception or not, you finally, you definitely execute this part of the code at the end. No matter what happens, this part is executed. Either you have an exception, you perform the catch, or you successfully finish the whole part of the try. At the end, you definitely have the finally part. So in the correct running case, statement 3, after statement 3, you will execute this one. Let's say this is called statement 5. After statement 3, in the correct execution, you'll continue with statement 5. If you have a catch statement, let's say statement 4, in the exceptional case, if the statement 2 generates an exception, you'll jump from statement 2 to statement 4, and then from statement 4 to statement 5. Okay? So that's basically the purpose of finally. The reason why you have finally is logical, actually, because in both cases you may want to, for example, let's say you would like to open a file. So let's say you have a try block, which is going to open a file here. I'm not writing the code. And then you're trying to read from this file. You have a file reader which you are going to read from. And then you definitely, in this case, if you have a file operation, if you do not write a catch IO exception, you won't be able to compile. This is called checked exception. So you will need to catch the IO exception. This is must. If you're anybody operating on files in the project? Nobody else? Have you tried to open a file and write into a file? So you need to have try and catch statements always, right? In file operations, since it is really common to have file problems, Java ensures you that, Java requires you to have the try-catch blocks, definitely. So you have to have the try-catch blocks if you're operating on a file. So you will try to open a file, and then if you, for some reason, if you cannot find the file, if the file cannot be opened, or if the file cannot be written, you will catch an IO exception. File exceptions are, in the IO exception class. If you catch this exception, what's going to happen is that you're going to write something like the file cannot be opened, or whatever you're going to useful, statements here. So if you cannot open the file, then however you have the file reader which you need to close, right? That is done in finally. Even if you catch an error, or if you process correctly, at the end you have to close the file. File reader. So this is useful because either this case or this case definitely requires you to close the file reader. So why have a line of close file here and then also close file here? Instead of that, you just write one close file with the final statement, which is going to make life easier for you. Okay? That's the main purpose of having finally. So that you don't need to repeat yourself here and there and just have one single line here. So if an exception is generated, the statements in the finally clause are executed after the statements in the appropriate catch clause complete. So as I said earlier, either you go after this one or this one to continue with the finally part of your try-catch blocks. Exception propagation. So if you have an exception that is generated in a method, let's say I have So let's say I have a main method which calls A, which calls B, and then which calls C. If an exception is generated here, if I'm not handling the exception here, this is going to be propagated up to the method B. And then method B is going to try to catch it if the try-catch block is there. If it cannot catch it, it will propagate up in the hierarchy, whichever called B is A, and in that case A will try to catch it. If there's the proper calls for catching it, it will catch it. Otherwise it will go all the way to the main, in which case you will just exit the application because you haven't catched it so far. If you haven't catched it in the main as well, then it will just exit the whole application. So this is the exception propagation. So let me open up this example code, and this will make it more clear. So let's see. Propagation. So public class propagation, and as you see, you have the main method which creates an exception scope object, which is a variable name is demo, and then you have new exception scope, and after you created the object, it is basically calling demo.level1. Okay, so let's go open up that exception scope file. So if you look into the exception scope, as you see, this is the first method that was called public void level1, and then you have system out print line level1 beginning, and after that it has a try level2, so it goes into the level2 method. Recall that propagation has system out print line program beginning, right? Program beginning will start there. Program beginning, and then you'll call demo.level1, right? So if I call demo.level1, what's going to happen? It's basically going to call this method, and then it will say system out print line level1 beginning. Level1 beginning. And then what is going to happen? It will call the try catch block. In the try, it will call level2 method. So it will call the level2 method, which basically has a system out print line level2 beginning. So it will print this level 2 beginning. And then what does it say? Level 3. It calls level 3. And then you have the level 3. So you have the int numerator 10, denominator 0, the 0 example, same thing, right? And then I have system out print line level 3 beginning. Level 3 beginning. And then it generates int result equals numerator divided by denominator. So what's going to happen here? This is going to generate a arithmetic exception. After that, what's going to happen? Is it going to print this? So what's going to happen? Since the exception occurred and it's not caught here, it's not going to print this, and then go whoever called this method. So what was this? What was the method calling this method? So level 2. So is this going to print this system out print line after this? No, since still this generated an exception, it will need to finish the execution. So it will go up one more level. So it will go level 1, whoever called level 2. So as you see here, this is where the exception occurred, and then this catch statement is going to catch that arithmetic exception, which happened in level 3. So basically, after that, it will be caught here, and then it's going to print this part of the catch, right? System out print line, the exception messages, problem, get message. So basically, the caught exception, whatever that exception is, indicated by the variable problem. Problem, if you have an exception, you can get the message that is associated with that exception by calling the get message method, so that you can print what happened there. So basically it is going to tell you that, hey, divide by 0 exception was generated. And then the call stack trace. So what does this mean? The call stack. If you call the problem print stack trace, it is going to indicate you the levels of the problem execution. You know, the exception is generated at what level and what were the levels in between here and there, right? So it's going to basically print the stack of the execution of the methods, and then it will print a line, and after that, once the exception is caught, it's going to continue with this line, so that after all these lines you're going to have the exception text here, and then after that you will have level 1 ending. Good exam question, right?
Sıraya level 3 yazsaydık yapar mıydı?
if you have written level 3, what was going to happen is that it will not start level 2 at all. So except this part, it should have been same, right? We can try. So let me execute this first. So basically it says program beginning, level 1 beginning, level 2 beginning, level 3 beginning, and then after that it comes to the try catch blocks catch part, right? So this is where the catch block happens. This is exactly what is going on here. The catch part, let me go there. So this is the catch part. It first prints the exception messages, whatever the message, and then the call stack. If you look into here, this is the message divide by 0. So the message is divide by 0, and then the call stack trace. So it indicates what was the error and where it happened. Java lang arithmetic exception divide by 0, and then exception scope dot level 3 method, and then level 2 method, level 1 method. Also including the lines of the code. Exception scope dot Java 54, 41, and 18. And then at the end it gives you propagation dot main, the main method of the propagation class, and then the line is line 17. And if you go into the line 17, as you see, it's going to basically indicate this propagation.java line 17 is where the method demo.level1 method call was made. Right? So if I happen to change this instead of level 2 and make it level 3, what's going to change? Basically, instead of calling level 2, it's going to directly go and call level 3, and only this part will be not included in the execution. So it's going to basically, what's going to happen? So as you see, it skips level 2, and then level 1, level 3, and then the exception is caught. From level 3 to level 1, it jumps, and then from level 1, it prints the exception and the necessary stuff that's printed. Any question? So this is exception propagation, and you have to look into the code and see where the exception happened and where it's actually caught. So as I said earlier, exception class hierarchy is starting from the object class. You have the throwable, which is basically the parent of both exception and error classes. Right? If you would like to define your own exception, you can use the exception class as a parent, and then you can create your own exception as a child of this exception class. Okay, so if you'd like to, for example, define a certain exception that's appropriate for your program, you can do so by, extending the exception class and then adding features that are necessary for your implementation. The parent class used depends on how the new exception will be used. For example, you could also use an additional, such as array-related exceptions. You would like to add an additional exception. You can do so by using the array exceptions and extend it further on. So as I said earlier, an exception is either checked or unchecked. What we mean by checked and unchecked is that for certain exceptions, you need to check the exception definitely. So for example, in this class, let me write it in bigger way so that you see. So exception, and then throwable is here. You have the runtime exception. And then you have the other rest of the exceptions that are available here, and also runtime exceptions is considered as another set. And then you have the error. So this part, error and runtime exceptions, are unchecked. Unchecked meaning that you don't need to necessarily check for these exceptions. If you remember the divide by 0, it is a runtime exception. So you don't need to really check this. However, if there's an exception, something like this happens, you don't have any way to catch it. However, for these checked exceptions, checked exceptions, you definitely have to have a try-catch block. Otherwise, your compiler will complain. So, for example, I/O exceptions is this type. So, if you're trying to open a file, you have to have a try-catch block or throw statement in order to check this exception. That's why it's called checked exception. Okay? So you have to make sure that either you solve it by a try-catch or you know that this kind of exception can happen. Okay? The compiler will issue an error if a checked exception is not caught or asserted in a throws clause. So I will indicate what I mean by throws clause shortly. So you need to either throw an exception or you need to use a try-catch block to catch those exceptions. However, an unchecked exception doesn't require explicit handling. However, if you would like to, again, as we did with the divide by zero example, you can do so by, by including the certain exceptions that you like. This part you don't have to. However, this part you have to. Checked exceptions such as file and stream operations and that sort of thing, such as URLs. For example, you would like to open a URL that gives you gives you a link. If you are not able to open up the link, then you have to check it first before operating on it. So you have to have a try-catch with URLs or files and things like those. Errors should not be caught, obvious reasons. For obvious reasons, you won't be able to catch them. And then also, they don't require a throws statement or try-catch as the runtime exception. So error and runtime exceptions do not require to be checked. The throw statement, as I said earlier, you can create your own exception and throw an exception if you like. Although the statement such as divide by zero generates an exception, you can issue an exception by yourself as well if you feel that's the proper thing to do. So let's see this example, creating exceptions, out of range exception. Out of range. So if you look into the out of range exception, this is a newly created exception by the user, just to have an additional exception. It doesn't do anything specific or fancy. However, what it does is that public class out of range exception extends exception. So you're basically extending the exception class and generating your own exception, which is out of range exception. And in this case, if you look into the constructor, basically what it does is that it gets a string message and then it basically calls the super message, which generates an exception with this message, which is the exception class's constructor. Okay, exception class accepts a constructor that takes a string that is a message, which indicates that message on the screen as a result. Okay, so whenever this exception is generated, basically it is going to, instead of the regular messages, call stack and everything, it will just print this message on the screen. So you can write your own exception by extending the exception class. And if you look into the creating exceptions class here, you see that the main method has two constants here. One is min 25 and the other one is max 40. It takes the user input and creates an exception that is of that class type, out of range exception problem, and you give the string that is the exception that you just seen. And it's going to ask the user enter an integer between min and max and read that integer. If the value is not within these limits, meaning that if the value is less than minimum or the value is more than maximum, throw problem. Problem was out of range exception. So if you would like to see the execution of this code, so as you see, enter an integer value between 25 and 40. If I just include something in between, such as 30, it's going to execute without any problems, end of main method. However, if you run it again with the range, with a number that's not in the range, such as 10, right? If I run this with 10, it gives you exception in thread main, out of range exception. Input value is out of range. So as you see, this is the exception string that you just generated. right? If you look into the code, normally if you didn't do that, you wouldn't have get that message. So input value is out of range is the message that you pass to the constructor of your out of range exception. So if you remember, this takes the message and then creates the exception using that message. That's why we see that string in the exception that is generated. Input value is out of range. How did we throw this exception? If you look into the code, you see that if this value is not between these ranges, throw the exception. So once you throw the exception, it just generates the exception, and then as you see, it doesn't write end of main at the end since you generated an exception. See, it doesn't say end of main method because you see that the system out print line comes after the exception. Why you may want to do this? Because if you would like to catch certain exceptions that you think are exceptions, you can generate your own exception, and this is useful in the sense that also you can use this in multiple places. Once you generate this kind of exception, you can use over and over in your application, such that, for example, if you would like the user to enter certain values throughout the program many times, hundreds of times, then you can just create one exception and use it over and over throughout your implementation.
Şu içerideki o input value is out of range var ya, onu girmeseydiniz, default bir exception tanımlasaydınız ne dönerdi? Throw problem deseydiniz.
If you didn't but the constructor for the out of range exception accepts a string message, and then you have to call the constructor of this using the string line, right? So if you leave it as empty string, it's just going to leave it empty. So if I just such as if I do get rid of this part and give an empty string, it's basically going to print an empty string. Like this, then it's going to give you a compile time error, right? You mean like this? So this doesn't accept any. So let's say I call 10. It's basically using the same, the string that it normally generates. So it's exception in thread main out of range exception at creating exceptions.main blah blah. Normal exception throwing is called. So exception has its own, own constructor with the string that prints the call stack. It will print that part only. Any question? So again, exceptions are important. We will continue after the break.